In this video, we're going to cover physical and chemical properties for our aromatic hydrocarbons. And just like with the other unsaturated hydrocarbons, we're just going to be recognizing reactions, not predicting products. And then we're also going to take a quick look at what we call fused ring aromatic hydrocarbons. So just like all of our other hydrocarbons, benzene is insoluble in water. It's soluble in other nonpolar solvents, less dense than water. Benzene specifically is colorless, flammable. It is a liquid at room temperature. And petroleum is our primary source of aromatic hydrocarbons, including benzene. As far as chemical reactions go for benzene, we do have all these double bonds, so you might think it reacts similarly to alkenes, but that is not the case. So aromatic hydrocarbons do not do addition reactions like alkenes do. Instead, they do what we call substitution. So what we're going to do is we're going to substitute or replace one of the hydrogens on the ring with a different group. So if you look at this example, we do know that all of these carbons have one hydrogen. So what's going to happen is we're going to take one of the hydrogens and replace it with this ethyl group. So we're going to substitute. So now we have this new bond to the ethyl group. That hydrogen is no longer there. We had to take it away. The other 5 hydrogens remain. So the hydrogen that we removed becomes the hydrogen you find in the HCl, and then the chloride comes from the other starting material. We can also substitute with other types of groups. So this first one was called alkylation because we're adding an alkyl group. We could also do chlorination, bromination, a number of other substitutions. So here we're adding bromine to the ring. So we're going to get rid of the hydrogen and add in a bromine atom instead. So again, the big thing here is to know that benzene rings do not do addition reactions, even though we think of them as having double bonds. Instead, they do what we call substitution. Then the last thing we'll talk about quickly are what we call fused ring aromatic hydrocarbons. So this is where we have multiple benzene rings and even sometimes other sized rings, 5-membered rings, fused together. So if we look at these structures, here I would have a benzene ring, and then I have a second benzene ring that is sharing 2 of the carbons from the first benzene ring. This is called naphthalene. And if you've ever smelled or used mothballs, mothballs are made of naphthalene. Here's anthracene. So in this case, we have actually 3 benzene groups that are fused together, sharing carbons on a side. So that's anthracene. And then we have phenanthracene, which is very similar. So again, 3 rings, but this time one, instead of being kind of straight across, we have one that angles up. So again, just recognize what fused ring stands for. We've got rings that are linked or fused together.